Alstom's the second largest passenger rail manufacturer in the world by volume of sales. We have the broadest geographic reach, just over 4,000 employees in the United States of America. We have manufacturing and engineering capabilities right here in the US. We build a lot of the iconic rolling stock and trains that you may recognize right here in Dallas. So for instance, the automated people mover at DFW and also at Houston International Airport is our Alstom products, as are the bi-level cars operated by TRE between Dallas and Fort Worth. We also build subways. We basically build everything from light rail vehicles all the way up to high-speed trains, and we're going to touch a little bit of all of that today during the presentation. Beyond just rolling stock, we also produce a broad set of signaling solutions. So the Electrologix brand, which is used by a lot of the Class 1 railroads across the United States, is an Alstom product, as well as we have CBTC, PTC, and various other urban and interurban signaling solutions. Just to get things going, in preparing for this conference, I thought it'd be a little interesting to take a little bit of a step into the past and look at the history of rail in Texas and the importance that rail has played in Texas. And I was truly impressed by the depth of history that rail has to play in terms of its background in Texas. Looking back to the 1800s, rail lines sprung up, connecting communities, allowing greater access to the interior of Texas, tying communities together. And no sooner than had intercity rail opened up than a host of streetcar lines sprung up in cities. And I was quite stunned by the volume of streetcars that we were talking about here. So San Antonio had 90 miles of trackage back at about the turn of the century. Austin had streetcars, Bonham, El Paso, Dallas, Houston, Fort Worth, Amarillo, Beaumont, Port Arthur, Corpus Christi, Waco, Laredo, and I'm sure I'm forgetting some. So just as rail was strategic in the formation of the United States, one also could argue that rail occupies a key place in the history of Texas. Going from the past and looking towards the future, what are some of the key trends that we see coming into the passenger rail market across the United States, North America as a whole? So there's kind of three columns that we're going to sort of focus on a little bit. Obviously, we're going to talk about green primarily, but we'll touch on a couple of other things. One is high-speed rail, in so much as I think there's more traction, both in Canada and the United States now, than there ever has been in the past for high-speed rail projects. More projects are actually concretely moving out of the planning stage and into execution than I think has ever happened in our past. And it's incredibly exciting and incredibly encouraging, and I know lots of folks are excited about presentations later today on the same topic. Equally, light rail has seen something, or streetcars, or LRTs, or tramways, or call them what you will, have seen something of a renaissance over the past 20 years in the United States, which is fantastic, and we see more plans to develop and expand systems going forward. Equally, as Peter mentioned, looking towards zero-emission solutions, be it in the freight space or in the passenger space, is a subject that's heating up tremendously as we look to decarbonize both freight and passenger rail and look for zero-emission solutions for moving goods and people into the future. So let's talk a little bit about hydrogen battery. And to kick things off, I wanted to share with you a little bit of background on a project that Alstom ran last summer in the province of Quebec up in Canada. Basically, what happened last summer is we brought in, there we go. We brought the world's first hydrogen-powered passenger rail vehicle, the Island, over to Quebec. We set up regular customer service, making it the first time that a hydrogen-powered passenger rail vehicle operated in commercial service in North America. The vehicle traveled between Quebec City and Bay St. Paul 4 times a week, distance of around 60 miles, roughly speaking, 4 days a week from June to September. It's actually a project that we've been working on since 2021, so it took us 2 years to pull the project together and involved multiple work streams, including technical, permitting with the authorities having jurisdiction, commercial work streams with our partners. Perhaps one of the biggest challenges was actually hydrogen. Just finding the hydrogen was a huge challenge, and I'll talk a little bit more about that later. Operations and maintenance logistics were significant, and so quite a lot of different work streams and work went into pulling the project together. Well, one question just to share that you might have in your mind is why would we choose Chemin de Fer Charlevoix, basically a small tourist line near Quebec City, as our target location? 2 key reasons. One, as it turns out, Chemin de Fer Charlevoix actually already operates EN standard vehicle as opposed to FRA standard vehicle. So from a crash worthiness and a safety perspective, we felt we had comfortable or a reasonable safety case to intermingle the new rolling stock, the Island from Europe, with existing. The second is a little bit more practical as well, which was with regards to signaling. It signals dark territory, so we didn't need to worry about onboard equipment and interfacing onboard equipment. Basically, it was a relatively straightforward thing to bring the vehicle across, drop it onto the tracks. There were a few modifications, and we have a couple of good stories if you have some time later to discuss about some of the modifications. There's a vintage bell that ended up from a locomotive on those vehicles. But putting that aside, it was a relatively straightforward exercise. One of the questions, so what is the Island vehicle? Often when I had the pleasure of introducing and receiving people up in Quebec City, the kind of first question is, well, I don't really recognize this vehicle. What exactly is it? It's not a very common type of vehicle to what we see over here in North America. So it's a regional train. Its job in life is to connect smaller secondary cities into major hubs so that people traveling by rail can get to a main line where they can get on a high speed or a higher density vehicle. So it's a low density vehicle. And the way I kind of explain it is it's kind of like the Greyhound bus is in North America. It's kind of the equivalent in Europe, except that it operates on rail lines as opposed to operating on road. And the difference in infrastructure, and Peter touched on this a little bit earlier, in Europe, the main lines are largely electrified. So high-speed trains and intercity trains operate on electrified lines. There's no need for decarbonizing those solutions. However, in Europe, the regional trains are still operating on lines that don't tend to have catenary. They're typically diesel multiple units. And as a consequence, the focus for decarbonization efforts is much more in the regional rail space in Europe than it would be necessarily over here. So a little bit of a difference in context, which explains why you see activity in hydrogen and battery happening more in the regional space than larger vehicles in Europe. Just to give you a little view of the from the driver's cabin, I mean, one of the things I didn't mention is Charlevoix is actually a UNESCO bioheritage reserve, and it's beautiful. There's bald eagles and mountains, and it's the estuary of the St. Lawrence into the Atlantic. You can go whale watching and stuff like that. It was I always felt it was a little bit painful to have to share with my family that I have to go off to Charlevoix again to receive people on a train. It was really a tough job to take for all of last summer. To speak a little bit about the operations, though, one of the feedbacks we had from our operators from Chemin de Fer Charlevoix was that it was a lot like operating the DMUs that they currently had in terms of performance. So the transition was actually relatively seamless. We actually flew operators from Charlevoix over to Germany, which is where the island's from, in order to get training prior to operations last summer, as well as actually the regulator. We flew people from the Ministry of Transportation of Quebec over as well. There we go. Just a quick view inside, spacious modern interior. Here I'll explain a little bit about how the vehicle operates. First I'll say that really the objective behind the project wasn't so much to prove that the vehicle worked. We knew the vehicle worked. The island's actually in commercial service in Germany. We have 2 customers in Germany who have bought full fleets to decarbonize entire lines. So these are smaller operators that operate basically an entire regional train network. Historically, they operated diesel multiple units. They swapped out all of their diesel multiple units with hydrogen-powered products with the island. So we knew the vehicle worked. Really what we were trying to show with the demonstration is, can we actually stitch all of the points together of an ecosystem to support a hydrogen train to offer commercial service on a regular basis? In other words, can we find the hydrogen? Can we get it there on time? Can we operate and maintain the vehicle? Can we get all of that put together to actually make real passenger service operate? Not just to do a one-off, but to actually, on a regular schedule, operate. And we were successful. But it did take a number of different stakeholders to pull it together in terms of our collaboration with our partners. So obviously the Quebec government was a supporter because they're the authority having jurisdiction and also a sponsor of the project. The railroad, Chemin de Fer Charlevoix, obviously a partner. Alnois Energy, which is actually a small energy firm, Quebec, supplied us with our hydrogen, and we're incredibly flexible, great partners to work with. And Cummins gave us some support with regards to the fuel cells themselves. Just because it's a good view of the train, you can actually see some of the parts, the moving parts, if you will, on the roof of the train. So if you can see, it's a little bit small, but there's a series of baffles on the roof of the train. Those cover the hydrogen tanks. By the articulation at the center, you can actually see the fans and the fan grills on top of the fuel cells. So basically, hydrogen from the tanks flows into the fuel cells where it reacts with oxygen to create electricity and give off water, nothing about water vapor. That electricity then flows to lithium-ion battery packs under the vehicle and to an electric powertrain to drive the vehicle. So in a nutshell, it's kind of like an electrical multiple unit, except that the power source, rather than coming from a catenary, is generated on board by a fuel cell, which gives off water and electricity, in a nutshell. Just some of the statistics to share with you in terms of what we were able to accomplish last summer. So we moved just over 9,000 passengers. Excuse for the kilometers, it's roughly 6,000 miles, just under 27 kilograms of hydrogen per 60 miles, roughly speaking. We offset a significant amount of CO2 as well for every train ride that we took. And then we refilled the vehicle 60 times. So where do we go from here? How do we see decarbonization of railroads happening in the North American context? Well, we have a multi-step plan which is coming into place. First of all, Alstom opened a Green Innovation Center just outside of Montreal in our St. Bruno headquarters for the Americas in 2022. The second step was this hydrogen demonstrator. We wanted to sort of spark interest in the possibility of zero emissions, and so this demonstration in Charlevoix was instrumental in getting that going and getting some of that excitement for the technology to happen. And then from there, we're in the process of rolling out and developing products which take some of that green technology, both in the hydrogen and battery space from Europe, and bring it across and combine it with North American solutions so that we can have solutions that actually can operate on FRA type equivalent. And we're looking at two types of solutions, both commuter trains or multiple units, as well as passenger locomotives. Just a word quickly about how do we see all of these pieces of technology working together. One of the questions we hear often is, well, there's electrification, there's batteries, there's hydrogen, and you get into these sort of wars, idealistic wars. Oh, hydrogen's going to be it. No, batteries have to be it. And our perspective is really all three technologies are complementary and each has their own place and own set of application. So let me walk you through it a little bit quickly. First and foremost, electrification, so conventional catenary overhead, still has a place in a decarbonized world. It provides an opportunity to provide power straight to the line, and in cases where there's enough trains operating with enough frequency or where the power requirements are significant for the trains, it makes economic sense to put the money into the infrastructure and not to have to put it on the vehicles, because you basically have a choice. Either you put power equipment on the wayside or you put it on the vehicles. So if you're running enough trains, the economics at one point tilt and make it make sense to put the money on the infrastructure as opposed to on the trains. In the case where you switch to having basically zero emissions, you switch to having lower density, the two technologies between battery and hydrogen kind of complement each other. So in the case of batteries, basically batteries operate well up into medium ranges, call it 60 miles, roughly speaking, and in cases where ideally there's some charging infrastructure, either catenary or some other means of recharging the vehicles, which already exists and is in place. Hydrogen excels where longer ranges are required. So when you need to go up to, and currently the state-of-the-art is roughly in the order of 600 miles. If you need to go to that longer distance, then that's where hydrogen can step in and can fill a space that the battery just isn't capable of doing. So taken together, it provides a toolkit. And our perspective is very much that it's going to require a full toolkit in order to look towards decarbonization going forward. It's not going to be a single solution which is able to address all the needs. Just one piece of feedback, too, that I'd share as well from our experience in Charlevoix, and a lot of the experiences going forward, is, in fact, one of the greatest challenges looking at zero-emission solutions isn't so much the vehicles themselves, although there are some technical challenges there. It's a question of infrastructure. And that is both charging infrastructure and hydrogen refueling infrastructure, and the availability of hydrogen is actually a little bit more complicated than we had originally conceived. Actually, even just for our demonstration in Quebec last summer, we had a little bit more difficulty than we would have imagined finding the hydrogen. So really getting that infrastructure piece in place is a higher stepping stone than even necessarily the vehicles. Certainly something we'd be welcome to discuss with folks if there's more interest. I should also just mention quickly, since I didn't have a lot of slides on batteries, that battery technology is something that we're advancing on. We currently have a battery multiple unit, so a regional train like the Island that I showed you that's operating on batteries in Germany, and we have orders for a number of more in Ireland and in Germany to complement that first one. I'm going to jump a couple of slides quickly to speak a little bit about light rail. So I'd ask you to bear with me in a little bit of editorial latitude going forward. Light rail might seem like it's a bit off topic, but you actually see it ties back into our theme of zero emissions. Just to speak quickly about light rail light rail is a fascinating solution that helps a lot of cities and developing communities to address some of the challenges that are forthcoming. And listening to some of the speakers yesterday, one of the points that I took away is that Texas is on the verge of a massive increase in population. And as that population increases, the demand and the needs for public transit are going to grow, and I certainly hope they're going to grow, and quite possibly in some cases exceed what can be addressed, certainly particularly with existing bus networks in cities and regions that don't have existing bus networks. And that's where light rail fills a perfect step up from a bus network to offer higher capacity at a cost which isn't quite as significant as going all the way to a full-on subway system with the cost and infrastructure impacts that can have. Light rail provides exciting opportunities for integrating with existing urban infrastructure, so it kind of fits into cities quite well. It's quite eco-friendly and is very attractive as a mode. In other words, it succeeds in attracting and exciting passengers to take public transit as an alternative certainly to driving in cars and things like that. Vehicles that can provide a solution, so modern streetcars or light rail systems like our Citadis can help operators in cities to meet some of these challenges. The Citadis offers a modern, comfortable ride, is extremely energy efficient, is accessible for all passengers. So by having 100% low floor, allows for roll-on or roll-off of people with reduced mobility, wheelchairs, mothers with strollers, people with bikes. You can get on and get off, hop on. It's a very fluid way, and certainly I know that there are light rail systems, of course, in Dallas and Houston, so it provides a real opportunity. I know a lot of you might be familiar with light rail systems. It's also a scalable system, and this is one of the things that's interesting in that it can go from almost bus-like performance in terms of how many people it can move, all the way up to very high-density systems which are almost subway-like in their capacity. They can be manufactured in the US and are compatible with a wide variety of different and modern signaling systems. One of the questions we get quite often is, how can we get rid of those overhead wires on light rail systems? A lot of people don't like the aesthetics. And so there's a number of technologies that exist, and we'll go into them in a little bit. One of the things that's interesting, though, is that some of the reasons for considering a catenary-free system can go above and beyond just the aesthetic question of, I don't want wires in my downtown. It can be things like areas where you have constraints in terms of not being able to put in poles or the infrastructure required for catenary. Or it can be things like, for instance, if there's EMI and RFI constraints due to university or a hospital or things like that, there can be a need to look for catenary-free as a means to mitigate some of those challenges. In terms of systems which exist, there's kind of two broad scopes of system which can exist to do a catenary-free system for LRV. One is a continuous power system. So this is a system we have called, Alstom makes called the APS, which is manufactured in Europe, which basically provides a continuous third rail which runs underneath the rail vehicles. And what happens is the system is electrified only as the vehicle rolls over the track. So basically, there's an RF sensor that turns on short segments of track as the vehicle rolls over to power the vehicle. And the upshot of that is it means that you don't need to have the overhead wire, but also you don't have to worry about the touch issue of people potentially coming into contact with third rail power, which obviously is a threat to human life and stuff like that. Great system, fantastic aesthetics, and the real benefit is absolutely no compromise in terms of vehicle performance. The other solution is a lot like electric cars, is to look at storing energy on board using batteries. And this is where the connection comes back to what I was talking about earlier in terms of zero emissions, in so much as the first instances of using lithium-ion batteries in rail vehicles actually came more through the LRV space than it did through the intercity space. So a lot of what we learned on LRVs in terms of deploying LRVs with batteries is actually now serving to expand into intercity operations and into larger and larger operations, which we're now seeing coming into the market and which we're working on. And we have solutions in Alstom. We actually make both solutions, both battery and third rail solutions, because the two have advantages and disadvantages. And again, very much like in the green space, we see the solutions as being complementary, and really it depends on what the use case is required for different situations. So then quickly, I just want to talk a little bit about high speed, and I'm keeping an eye on the time if Peter's is as well. So of course, you'd be right to say, well, this is the green scene. Why are we talking about high speed? And so one of the things I just wanted to share is that high speed is possibly the single most energy efficient means of land transportation. In terms of energy used per passenger kilometer, there's nothing better, even than other types of passenger rail. It's absolutely fantastic from an environmental perspective as a means of moving people. In cases where the electrification comes from a zero emission source, it's even better in that it can be an entirely emission-free solution. Very quickly, what are some of the incentives we see behind high-speed productivity? Train time is productive time, as I'm sure many of you in the room have experienced riding Amtrak or other passenger rail services. The benefits to security and that rail is incredibly safe. One point that I think is really important is access to employee base and access to affordable housing. And that one of the things that high-speed rail has the power to do is to shrink distances between cities, and in so doing to reduce the time that it takes and provide easier access to adjacent communities, both for employees and for employers. And of course, there's the opportunity for enhanced multimodal connectivity in connecting with airlines to provide almost like a last mile solution into aviation. Where does high-speed rail fit? I mean, one of the things that the questions is so how can it be applied? This is a little bit of data that we've collected in collaboration with the UIC and from our own experience in Europe. Basically, the takeaway, there's a sweet spot at around 3 hours travel time. If it's 3 hours or less, people are willing to take the train. Doing the math, 3 hours at roughly 200 kilometers per hour means that sort of the max range that fits well in terms of convincing people to take the train is around 600 miles, but there's a sweet spot roughly around the 300-mile point in terms of city pairs. So if you look at a lot of the city pairs in Texas, it's certainly a key use case which fits for a number of the different cities across Texas. Just to share really quickly, and certainly Amtrak's here, and we'd certainly like to recognize our customer for whom we're very proudly, that we're developing currently and delivering a high-speed train manufactured in the United States, the Avelia Liberty, which is capable of operating both on dedicated lines but also in mixed traffic in that it is designed to meet FRA standards. So how does this map onto the future of rail in Texas? Well, I'd say just about all the pieces that we mentioned have a place or role to play in the future of rail in Texas. Be it existing light rail systems that are looking for new technology. There's exciting new technology which is coming out which can make existing systems even better. In the case of new light rail systems, there's new standards of equipment and technology and solutions which can offer possibilities beyond what's been contemplated before. In terms of commuter rail, whether it's decarbonizing existing commuter rail, building or establishing new commuter rail or new intercity rail links, the zero emission solutions we discussed can play a role in terms of decarbonizing and offer exciting, comfortable, and compelling way to travel. And of course, high speed has a role to play in offering new service across Texas and across the region. So I think altogether it's possible that the technology exists to build a future in rail which potentially could even surpass some of the extraordinary accomplishments of Texas's rail history. Thanks very much.